All right, guys, final section of chapter 2. Let me start you out with just a couple of the theorems and postulates that are going to come up in this section. Angle addition, we've already talked about. It's the same thing as segment addition, but with angles. So it's like this small angle plus this small angle equals the whole thing, right? So you would say angle PQR, that's the little guy, plus angle RQS, that's the medium-sized guy, is equal to angle PQS, which is the whole thing, the big guy. All right, so that's one we're going to see quite a bit. The supplement theorem just talks about having a linear pair. Whenever you are told that you have a linear pair, if this was given to you, then your conclusion would be that the angles are supplementary. And so that's something we'll know is true. Guys, that idea of supplementary angles is synonymous with the equation that they add to 180, right? And so we're going to be putting this whole thing to use anytime we see we have a linear pair, or if they were to tell you have supplementary angles, right? This is an equation that we could write. So this is what our linear pair looks like, just a pair of angles that form a line. And then the complement theorem is like the same thing, only it's complementary instead of supplementary, right? So it's 90 degrees instead of 180. So this one starts out with just some basic algebra stuff, and this stuff is right out of chapter 1. So if we look at this one, we're told that angles 1 and 2 form a linear pair. So right off the bat, we know that they add to 180 because they're supplementary. Remember, that's called the supplement theorem. That's what's allowing them to write this equation right here. So if that's what I was given, then this is the statement and the reason that I would be allowed to write, right? So I can write this equation and I can give it this reason based on what we just saw up above. From here we can fill in the numbers, right? I know that angle 2 is 115. They told us that right here. So that's being plugged in for angle 2, and then a little algebra, and you figure out that angle 1 is 65. So same thing would be true with your complement theorem. So if you're told that two angles form a right angle, all right, then that would tell you that they add to 90, and that's our complement theorem. We can sub in the information they gave us. It's 20 degrees for angle 2. And then a little algebra, we figure out that angle 1 is 70. So the first part of this is just doing some problems along those lines, and you actually saw these types of things on our chapter 1 test. So some pretty similar diagrams to this. So one thing we got to make sure that we do, though, that's going to be a little different in this chapter from what it was in chapter 1 is they're trying to use something that you're already familiar with and help you organize it now into doing a proof. So we need to be able to give a reason for each step that we take. So first thing first, as I look at the diagram, I can see that 7 and 8 are a linear pair. So this is like my given information that I have a linear pair. So the equation that we'd be able to write, let me get this out of the way, so I'm not going to have enough room here. So the equation that I would be able to write is that the measure of angle 7 plus the measure of angle 8 is equal to 180. And they want us to give a reason or name the theorem that justifies each step. So what allowed us to write that? That would be our supplements theorem that we just saw from up above. We will abbreviate just like they do. All right, so where do we go from there? Here's where we can substitute in the information. So I'm going to replace angle 7 with 5x plus 5. I'm going to replace angle 8 with x minus 5. Got my 180. Again, got to give a reason that justifies the step. That was substitution. So it looks like this. From here, I would simplify the left side by combining like terms. So I'm going to get 6x. Those guys would cancel. So I get 6x equals 180. And again, this is that sort of weird step of algebra where the book, for some reason, wants to say that this is substitution. I don't really agree with that, as I've already explained, but so I would have said something like simplify or combine like terms, I would have said one of those two things. And then what would you do from there? We would divide both sides of the equation by 6. So we are going to say that is our division property of equality. So that's what it should look like. Guys, one thing that we got to make sure that we do is, and this is such a big issue in this class all year long, you have to see what it is that they're really asking you for, right? Because sometimes they just say, solve for x. And if they said that, we would be done at this point. But that's not what these said. These said find the measure of each numbered angle, which means they want to know what's the measure of angle 7 and what's the measure of angle 8. So we'd actually have to take this, plug it back in order to answer that question. So if I took my 30 and plugged it back in for x, then the measure of angle 8 is 25. And then you could also plug this back in for x to get angle 7. Another approach would be, we already know they add to 180, so if I wanted to at this point, I could just subtract this from 180 in order to get angle 7. That works too. So whatever gets you there. The one benefit about actually plugging it back in for x is then it's kind of a way of checking your answer. If I plug this back in for x for angle 7, so 5 times 30 is 150, plus 5 is 155. Now I can check my answer by seeing if they add to 180, which they do. So that's kind of a good way of checking your answer. So anyway, let's go on to the next one. So now this one is really the exact same idea, only now you have 4 angles instead of 2 forming a line. So I wouldn't call this a linear pair. However, these angles still form a line which adds to 180, which is still supplementary. So I can still identify this as the supplement theorem. So I know that angles, so we're going to squeeze all this in here. So measure of angle 5 plus measure of angle 6 plus 7 plus 8 all adds up to 180. And again, they do say justify each step. So we would need to write next to this, we need to write the supplements theorem, right? Because angles that add to 180 are supplementary. So we're going to call that our supplements theorem. From here, we would start subbing in the information. So I'm going to replace angle 5 with the 5x. Angle 6 is right here. It's 4x plus 6. 7 is 10x. And 8 is 12x minus 12. Still equals 180. And again, guys, it's really important, especially when you're doing the homework, to follow the directions. And if they say name the theorem, you got to name the theorem or name the steps of what you're doing. Right? In this case, I would call this substitution, just like we did here. I'm just not writing it all out because I'm going to run out of space. So, and then from here, you would go on to simplify and solve. Not a lot different than what we did in the previous one. Right? I just wanted to make sure you see how to set these up and make sure you follow directions. Right? So when it tells you to justify things, and make sure that you give the reasons accordingly. Let's look at one last one. So what would have been nice is if they would have given us something that matched our complements theorem, because all the ones they're giving us, like angles 11 and 13, it's just another linear pair. So I'm going to cheat a little bit on this one, and I'm going to give you a new diagram. So that it matches the other theorem. So first things first, it is now, it's now given information that this is a right angle. So let's see, I'm going to call this one angle 11 and this one angle 13. So now when I look at those, I can say, okay, if I'm told that this is a right angle, then I know that the measure of angle 11 plus measure of angle 13 is equal to 90. right? And the theorem that would justify that is our complements theorem. So again, need to write that kind of thing when the directions tell you to. And then the rest is going to play out just like the previous two. We're going to sub in the information. So 11 is going to be replaced with 11x. 13 is being replaced with 10x plus 12. And then again, I could go on, solve for x. This is my substitution move. So if they want me to justify all my steps, then that's what I would put. But again, you could go on and simplify and solve same way that we did on the first one right here. Let me get to the last page, or second page of this, and introduce you to the final reasons for the chapters. So this is again why I really hope you guys print these out, so you don't have to rewrite all this stuff. I want you to have these for your notes, but not have to write it all. So if you print it, that's awesome. So let's quickly go down the list here and talk about these guys. Our congruent supplements theorem and complements theorem are kind of the same thing, only obviously one adds to 180, the other one adds to 90. So here's what they say. Angles that are supplement to the same angle, or congruent angles, are congruent to each other. So here's what that means. This is easier if I give you a picture for this. Let's just say that angle, I'm going to call this, we'll call it angle 1, which is, I'm going to say 60 degrees. I'm going to have angle 2 be 120. And over here, I'm going to draw angle 3, which is 60. Okay, so if you look at these, here's what the congruent supplements theorem says. We agree that, I'm going to call this 2 and 3. So we agree that angles 1 and 2 are supplementary, right? They add to 180. I'm going to say that 2 and 3 are supplementary because they add to 180. So what you're seeing is, and this is a lot like our transitive property, what you're seeing is that angles 1 and 3 are supplementary to the same angle. Right? They're both supplementary to angle 2, which means in order for them to be supplementary to the same angle, they have to be equal to each other. So if I am told that 1 and 2 are supplementary, I'm told that 2 and 3 are supplementary, then my conclusion in the next statement should be able to say that 1 and 3 are congruent to each other by the congruent supplements theorem. Complementary is the exact same thing, only they add to 90 instead of 180. All right, so congruent complements will be the same thing. Vertical angles we've talked about since chapter 1. Vertical angles are ones where if you have like an X, like something like this, this was on our quiz for this chapter. Vertical angles are across from each other. So like those two would be congruent to each other because they're vertical. These guys would be congruent to each other, right? Top and bottom, because they are vertical angles. So if two angles are vertical angles, then they are congruent to each other. Typically, that'll just come from a diagram. If you see a diagram like this, and let's just say they call this angle 1 and this is angle 2. If I just see that in the diagram, I should be able to automatically say in my proof, angle 1 is congruent to angle 2, and my reason would be vertical angles theorem. All right, perpendicular lines intersect to form 4 right angles. That was on our quiz for earlier this week for this chapter. All the right angles are congruent. Guys, these, by the way, these don't have names, at least not in this book. In our last book they did, but in this book they just have numbers. Don't memorize the numbers. I don't want you to memorize that. If this ever comes up in a proof and you have to give a reason, just say this, right? So if I see that I have 2 right angles, and in my proof I want to say that they're congruent to each other, my reason is going to be this. All right angles are congruent. Right, so we're not going to use names for some of these. We're just going to simply state what the theorem states. Perpendicular lines form congruent adjacent angles, and that would make sense because they're all 90 degrees. They're all right angles, so they would have to be congruent adjacent angles. This is one we don't use a ton. If two angles are congruent and supplementary, then each angle is a right angle. And this is almost just logic. If I have two angles, if they're the same and they add to 180, well, they would have to both be 90 degrees in order for both those things to be true. Right? The only way they can add to 180 and be the same angle is if they're both 90 degrees. Right? And so they must form a right angle at that point. So that one's really more logic than anything else. If two congruent angles form a linear pair, then they are right angles. This is like the same thing as this one because linear pairs are supplementary. So these two things almost say identical statements. Of these 5 that you're seeing right here that don't have names, by far we would be using the first 2 more than anything else. So these are the ones that will be the most common that we would see come up in proofs. These are definitely logical ideas that we want to hang on to. They're just not as often seen in a proof. Those 2.9 and 210 are more common. So let's go through a couple proofs. Remember, this section is a focus on angles. So all these things are going to involve angles for 2.8. So here's a nice short 3-step proof. Let's take a look at the one they did. As always, took all the given information, put it into statement number 1. That's our reason, right? And this is the way I like doing it. So I kind of like seeing this proof because I'm used to taking all my given information, putting it under my first statement. And then we can use it as we see fit throughout the proof. So anyway, where did they come up with step 2 here? So if you look at what they said right here, they said that DBE and CBD form a right angle, therefore they are complementary. Right? This was on the other page that we did on the first part of the first half of the lesson. That says if you got right angles, then they must add to 90 degrees. Therefore, they are complementary. And that was simply the complements theorem. Right? The complement theorem. That was similar to the one I sort of wrote in as number 3 on the previous page at the very end of the previous page. So that's our complement theorem. So here's a new one that just came up. If ABC and CBD are complementary, DBE and, again, CBD are complementary. So notice these two angles are complementary to the same angle. And the only way for that to be true is if this is congruent to this. And so that's what they said as their final statement. That is our So what they did on this is instead of writing the name, congruent complements theorem, they wrote out what the theorem says. And we've talked about this before. That's fine. You can either write the name or you can write what it says. Right? And I'm okay with either one. If we would have said I've always written this one as our congruent complements theorem. So you could write it that way too. All right, so let's fill in some blanks. Always welcome to pause and work ahead of me a little bit on these. So let's fill these guys in. Notice first one, of course, is our given. We're told we have perpendicular lines. That's a little T, right? It means that AB is perpendicular to BC. So we should be thinking right off the bat, what do we know about perpendicular lines, right? What do they form, right? We know they form right angles. And so we're going to get to that one here right away. They did not use all their given in the beginning. 1 and 3 are complementary. Oh, that was down here in our given for G. So angles 1 and 3 are complementary. All right, so let's go back up here. So if two lines are perpendicular, then we know that they form right angles. So if you look at AB and BC, so if I put those two angles together, they form angle ABC. So we know that angle ABC is a right angle. That's the definition of perpendicular. It says that the perpendicular lines form right angles. So we know we have a right angle. How do we go from knowing that we have a right angle to its measure equaling 90 degrees? And that's just the definition of a right angle. So if definition of a right angle says that the angle measure is 90 degrees, right? And so that's where we get to this guy. As far as D goes, if you look at your diagram, ABC consists of angles 1 plus angle 2. That is our angle addition postulate that came up in this section. So that's our angle addition postulate. So here's where something we got to recognize is substitution at this point. These guys both equal angle ABC, right? So if ABC is 90, that means I can sub in my 90 degrees in for ABC. So 90 equals angle 1 plus 2. There's our substitution. You could actually use transitive for that one if you wanted to, because you're saying that idea of if these two things both equal ABC, then they also must equal each other, right? And so you could also argue that as a transitive property. From here, how do we get from 1 and 2 adding to 90 to 1 and 2 being complementary, right? So this is the new one for this section that we saw on the front page, that if two angles add to 90, then they are complementary. That is simply our complements theorem. We already talked about this being given. Here's one of the new ones that we saw just a little bit ago up above. Notice the words complementary, right? 1 and 2 are complementary. 1 and 3 are complementary. So what allows us to say 2 and 3 are the same? And this is that new one from up above that we said, if these angles are both complementary to the same angle, sorry, let me get my thumb out of the way. If these two angles are both complementary to the same angle, they must equal each other, right? So that therefore 2 and 3 must be congruent, and that is our congruent complements theorem. You can abbreviate, or you can actually write out, like they did in the previous proof. You could actually write out the whole thing if you really want to. All right, let's go to one last one. We'll close out the chapter here. So as you look at this one, you can see here's all our given information. They used it all right away in the first line. So that's good. All the givens out of the way. Always good to note what it is we're trying to prove. Right, I'm trying to prove that 2 and 3 are congruent to each other. Right, so that's the goal here. So if I look at what I have, if 1 and 2 are a linear pair, which I can see by the drawing, then I'm allowed to say that angles 1 and 2 are supplementary. This is what we went through at the very beginning of this video on the first page. And that is our supplements theorem. So what's allowing them to say that 1 is supplementary to 3? If you look back up at our given right here, we're told that 1 plus 3 is 180 degrees. So if they add to 180, we know that makes them supplementary, and that's just the definition of supplementary angles. The definition of supplementary angles says if two angles add to 180, then their measure is, or then they're identified as supplementary angles. So we're just going to call that the definition of supplementary angles. So now look at what we have. This takes us back up to the drawing I was talking about when we did this a few minutes ago. If we see that 1 and 2 are supplementary, 1 and 3 are supplementary, that must make 2 congruent to 3 by our congruent supplements theorem, or you can write it out like they did. So we're going to finish this off by saying angle 2 is congruent to angle 3 by our congruent supplements theorem. So that is it. That's the end of chapter 2.